sir.
Hi students, welcome back to our JEE Main paper analysis series. Students, today now we're going to take live on 25th February shift 2 physics paper analysis. Students, I would like to say the morning first shift is a bit more difficult and lengthy than the shift 2 examination, students. So let us go through the journey of this paper analysis. So the questions are based on memory, and now we are going to discuss some conceptual things and what are the solutions for them, and how you can prepare for the further coming sessions from this paper analysis. A solid sphere, this is the first question, students. A solid sphere as shown is rolling without slipping. Find maximum length travelled on an inclined plane. Students, if you would have practiced, you might have seen similar kind of questions. A solid sphere coming from a height from the inclined plane, and what is the final velocity when the sphere has reached the bottommost point. So this is a reverse question to that. So where while the sphere is coming from topmost point to the bottom point, the potential energy of the sphere is getting converted into, because it is rolling without slipping, it will be converted into kinetic energy, that is translational energy, plus which comprises of translational energy and also rolling, that is rotational kinetic energy. Now the two energies will transform to, in this case these two energies will transform to potential energy. So what we can say, students, here, what is the translational energy? Half mv naught square, as shown in the figure. The mass is m and v naught square, plus what is rotational kinetic energy, that is half into I omega square. I of a solid sphere about its axis is 2 by 5 mr square, into omega square can be written as v naught square by r square, because v naught is equal to r omega for pure rolling, So if we calculate and equate it to mgh, you can see here r square cancel, half mv naught square we can take common, to 1 plus 2 by 5, that will be 7 by 5 into half mv naught square is equal to mgh. Cancel, so v naught square will be equal to root over, so this will be the height. What we need to find out is length, students. So from the diagram, so h is, if you are able to find out h, then from it sin theta is equal to h by L. So if you are able to find out what is the maximum height it can travel, then h is equal to L sin theta. You try to equate, then you will be able to get the answer. L will be equal to h by sin theta. From here if you get h, students, then this 2 gets cancelled. From here if you get h, then you will be able to get the length, students, by dividing it with sin theta. That is the approach, students, here. So here the length will be 7v square by 10g sin theta is the correct answer, students. So now a unit, let us see the next question, students. A unit mass particle is moving in a circle of radius r such that its projection on a diameter. So this looks something similar to you. You might have seen that its projection on diameter is actually what? A uniform circular motion of a particle, and its projection on diameter can be described as simple harmonic motion. And by using phasor analysis also, you will be able to solve number of problems on phase in simple harmonic motion. So that's a part of discussion for another lecture. But now what you need to find out, find the force acting on the particle at position B if it starts from A. One hint he has given you, students. Position B, what is the distance from the mean position, students? It is a maximum distance from the mean position, that is what? Amplitude. So then what is the force on a particle, students? You know force is equal to kx. Is a simple equation of a simple harmonic motion, that is minus kx you will write sometimes just because the force will be opposite to the direction of displacement, students. So if F is equal to minus kx, in magnitude wise F can be written as kx. So what, at the extreme position at B, that force will be equal to Ka, students. Ka, because x will be replaced by a, and this k can be written as m omega square a. We know that omega square is equal to k by m omega square. M is unit mass here, students. A amplitude is this a, students, that is amplitude is nothing but radius here. So answer will be m r omega square will be the force. So what is omega? Here we need to find out omega from the hint that he has given. So uniform circular motion, the projection of that is only the simple harmonic motion. So if it is uniform circular motion, we can write as omega is equal to theta by t, theta is equal to omega t. So what is omega here? How much angle they traveled? 30 degrees, that is pi by 6 traveled in how much time, students, here? 0.1 seconds. If you apply this, then what you can do is you are able to get omega that is equal to pi by 0.6. If you know omega and supply here 1 into r is 0.36 into omega square is pi square by 0.6 here, so you will be able to get the answer, that is pi square will be around 9.7, students. So this will be pi square. So now, so let us see here, students, what is the proton and electron are moving along with a circular path with same speed. Find out the ratio of de Broglie wavelengths. So this is also repeated in nearly other shifts as well, similar kind of questions. What is that, students? Lambda de Broglie's wavelength is equal to h by p, students, here. So lambda of a proton can be written as, how can we write this, students, here? Lambda of a proton can be written as h by momentum of a proton, that is mass of a proton, into velocity of a proton. Lambda of a electron can be written as h by mass of an electron into velocity of an electron. So another thing he is told is both are having the same speed. So then what is the ratio of de Broglie wavelength? That is lambda e by lambda p is equal to h gets cancelled. So that will be 1 by MEV divided by 1 by MPVP. But he told speeds are also same. So then the ratio will be mass of the proton by mass of an electron. So that we know mass of a proton by mass of an electron is 1836, that is given in the question. So the answer will be 1836, students. So let us go to the next question, students. In a given AC series circuit containing elements R, L and C, source voltage is 220 volts. It is known that if L alone is removed, carefully listen here, students. If L alone is removed, or if C alone is removed, phase difference between current and voltage remains 45 degrees. You know AC circuit, students. So in inductor current lags, in capacitor current leads. So what we can say is, if both are removed, if either one is removed, if L is removed, if C is removed, the phase difference is 45. If L is removed, the phase difference is 45. That means what he wants to say is the magnitude of inductor resistance, that is omega L, because both are making an angle, same angle in magnitude wise, the difference. So omega L XL should be equal to XC, that is omega L should be equal to 1 by omega C. If this is the hidden motive of the examiner to convey us that this circuit follows resonance. This circuit follows resonance. If it follows resonance, then how can we answer it? So when both are there, the answer will be I is equal to potential difference by root over R square plus XL minus XC whole square. And now XL is equal to XC, the answer will be V by R. What is potential difference here, students? This from here is a cakewalk, is 110 volts, 110 ohms. Then the answer will be 2 amperes. This is an obvious question just from this hint of 45 degrees. When L or C is removed, you should be able to understand this is a resonant circuit in resonance. So then what is the next question? If an electron of a hydrogen atom jumps from n is equal to 2 to n is equal to 1, then find the wavelength of released photon. So already this similar kind of question has appeared in the previous shifts as well. Not exactly the same question, the concept based on this question. So what did we discuss there here? So what did we discuss there here, students? So the energy is equal to, can be written as, energy difference can be written as 13.6 into 1 minus 1 by n1 square minus 1 by n2 square, that will be 1 square minus 1 by 4, that can be written as 3 by 4 into 13.6. This will actually, this energy, whatever the electron has lost will be released in the form of photons. Whatever the electron has lost the energy, that energy will be released in the form of photons. Photons energy can be written as, you might have known this formula, students, h mu. This can also be written as hc by lambda. This can also be written as, if we convert the values 1040 by lambda in nanometers, or otherwise 12,400 by lambda in angstroms. So if you equate them, 1240 by lambda in nanometers, and if you substitute, you will be able to get, this also is in electron volts, 13.6, then you will be able to get the value of lambda just by substitution, equating the energy loss of electron is the gain of energy of the photon. So if you are able to equate, then you get the answer here, students. So the answer here is, according to the question here, 1 to 1.5 nanometers. So let us go to the next question. So this is a beautiful question to answer, students here. So what is the beauty of this question? This question is similar to the question that you have solved in projectile motion. So just try to understand and analyze how this question can be solved. An electron enters in a capacitor, making an angle alpha with the plate or plane, making an angle alpha with the plane, having kinetic energy K1, okay, and comes out with the kinetic energy K2, making an angle beta with another plane. To find the ratio of K1 and K2. So students, so this is a question similar to what you have studied in gravitation, students. So here what will happen in capacitor, one plate is positive, means another plate will be negative. So there will be a uniform electric field. So that might be in any way. So that might be from, this might be positive and this is negative, or this might be positive and that might be negative. But what happens is, along the direction of electric field, there will be a force on the electron, that will be EQ, that is EE by mass of an electron, and there will be acceleration to the electron in this direction, opposite direction to the electric field. That means if electric field in this direction, electron acceleration will be opposite direction to the electric field. So what happens here, students? So you might have studied in gravitation for a projectile motion thrown with theta angle with the horizontal. What will happen, students, here? Because the acceleration due to gravity is downwards, there will be a change in the velocity of the vertical components of velocity. Always at any point you can resolve the velocity into two components. One will be Vx and other will be Vy. Here there will be very high quality point, students, that there will be a change in the velocity of vertical component throughout the motion because there is a constant acceleration acting in the vertically downward direction. Similarly here, due to electric field, there is an acceleration to the electron in the downward direction because if the electric field is upwards, or otherwise vice versa. So there will be a change in velocity of the electron in the vertical direction, but in projectile motion is students, always at any point the horizontal velocity will be same. Anything you take, Vx is always equal to ux plus axt, x is 0, so Vx is equal to uxt. Similarly, perpendicular to the electric field, the electron velocity will remain same, students. So if somewhere, if the electron is leaving out of the capacitor with V2 velocity, it will have a horizontal with beta angle, horizontal component of V2 cos beta here, students. So this is V1 cos beta, cos alpha when it is entering, V2 cos beta when it is going out, are the two components of velocities perpendicular to the electric field. If it is perpendicular to the electric field, students, if it is perpendicular to the electric field, there will not be any change in the velocity, students. If there is no change in the velocity, students, so then what can we say? We can equate them. How to equate them? So how to equate them, students? V1 cos alpha horizontal component should be equal to V2 cos beta. This from here it's an obvious question. If you know V1 by V2 is equal to cos beta by cos alpha, then what velocity speeds you know, students, and the rest is you can do kinetic energy ratios is half mv1 square by half mv2 square, half m cancel and squaring on both sides. The answer will be cos square beta by cos square alpha. But this concept is highly important, students. It might appear in the coming shifts or in the coming next turn of mains examinations as well. This concept is, you need to be clear in this concept. So let us see, students, here. An electron enters, the answer will be cos square beta by cos square alpha. Now here sunlight is diffracted. This is also based on diffraction, students. This is also a quality question you might have studied. So when you send light through an aperture, there will be a diffraction pattern seen on at a distance d here. So we can say at a distance on the screen we can see the diffraction pattern similar to this. Might have studied. Here this will be the central bright fringe here, students, and this will be formed in the form of a ring. If you observe from this cross section, you will see the form of a ring, a bright ring that will happen. So what is the radius of this ring, students? That is 1.22 lambda by 2a. 2a is diameter, students. So now here, you students, the diameter is increased, the aperture diameter is increased. If aperture diameter is increased, that radius will decrease. Radius of the central fringe decreases, means size of the circular fringe will decrease. So that is an option given in two places. But another point here, students, in diffraction or interference, energy will be redistributed but cannot be dissipated. If somewhere energy is lost, it will reappear in another place. So here the energy that is lost in the other part of the ring which has decreased, the energy will increase here, so the intensity of this ring will increase. In other way also you can solve this, students. In what way is, you know, amplitude in interference you have studied, amplitude will depend upon width of the slits. If the aperture width is increased, then there will be increase in the amplitude. If there is an increase in the amplitude, there will be an increase in the intensity as well, intensity proportional to amplitude square. So if the width of the aperture increases, then amplitude and as well as intensity will increase. So intensity will increase and size of circular fringe width will decrease. You can go through the NCERT textbook as well to find these important fundamental points. So students, next question. So this is a very easy question from units and dimensions, students. So how to solve this equation, students? How to solve? I don't think I need to solve this question, students, but still for you I am going to solve this. Find out dimensions of E square in an easy way if possible. So if you see here, can you see it as K Q1 Q2 something similar to electrostatics, Coulomb's law? What does it say? Force between two charges is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, isn't it? So now here 1 by 4 pi epsilon naught E square is two charges E and E if I consider. So this is similar to this. So can I write it as 1 by 4 pi epsilon naught Q1 Q2 is equal to FR square, force into R square. Can I write it as force into L square? So force into L square by Hc. Hc is nothing but, you might have seen a formula of containing Hc, that is energy is equal to Hc by lambda. So then Hc can be written as E lambda, energy into lambda. So this can also be written as H3 can also be written as Hc can also be written as E into lambda, that is F L square divided by energy into lambda. Lambda is L. So L gets cancelled. So what is force here? Force dimensions you know, mLT power minus 2 and into L divided by energy is mL square T power minus 2. M gets cancelled. L square gets cancelled. T minus 2 gets cancelled. I don't know, he wanted you to find out finally a dimensionless quantity from this question. Just apply the basics. Just apply the basics. You will be able to solve many questions in this paper. So next, rotational kinetic energy of a gas molecule follows Maxwell's speed distribution. Next point is rotational kinetic energy and translational kinetic energy of a diatomic gas molecule is same. Students, carefully read the statement, students here. What is the distribution given by Maxwell? What Maxwell has given is, if you would have remembered the Maxwell distribution curve, he told the number of molecules in a particular given volume and the temperature. So temperature means you can consider kinetic energy as well, because kinetic energy is proportional to the temperature of the molecules. So he has given this distribution, students. So but here he is telling about rotational kinetic energy of the molecules with speed distribution curve. No, he gives number of molecules with temperature and also speeds of the molecules. So this is, Maxwell does not describe about the rotational kinetic energy of a gas molecule, students. Then what is the next point? Rotational kinetic energy and translational kinetic energy of diatomic gas molecule is same. Students, you might have studied a very important concept here. The rotational kinetic energy is nothing but degrees of rotational degrees of freedom by 2 into RT for moles, or otherwise rotational degrees of freedom by 2 into KT for molecules. Similarly, for diatomic molecules, what are the degrees of rotational degrees of freedom, students? For a diatomic molecule, if you draw, it can for a diatomic molecule, it can rotate about y-axis. If it is on the x-axis, rotation about that x-axis is 0 because the molecules are exactly on the x-axis. So about y-axis and about z-axis there will be 2 degrees of freedom, students. So then that will be 2 by 2 kT, that will be 1 kT will be the rotational kinetic energy, students. Whereas translational kinetic energy, you know, it has 3 degrees of freedom, students, that is x, y, z. It can translate in x, y, z, students. So that means 3 degrees of freedom, that energy will be 3 by 2 kT. If you observe, the rotational degrees of freedom are only 2 and translational degrees of freedom are 3 for a diatomic gas molecule, students. So then they are not equal. So statement 1 as well as statement 2 both are false, students, both are false, both are false. You can go through the theory as well. So students, next, coming to the next question, students. So this is the last question. This you can do as well by using photoelectric concept. Photoelectric concept. What does photoelectric concept say? Photoelectric effect of a certain metal, the stopping potential is 0.71 volts. If the wavelength of incident radiation is 491 nanometers, now the stopping potential comes out to be 1.43 volts if the wavelength of incident radiation is. So there are 2 situations here, students. Initially, on a certain metal, incident radiation is of 491 nanometers. So what we can say by using photoelectric equation, so incident energy is equal to kinetic work function of the material plus kinetic energy, that is EV max, maximum kinetic energy of the, so whatever the energy that photon gives will use up in removing the electron from the metal surface, from the metal, that is work function of the metal, and EV max is the kinetic energy of that electron after being removed. So the total energy is used up in these 2 parts, students. So if you apply the 2 equations, first case stopping potential is what, 0.71 volts, students, here, plus phi is equal to, this will be h mu, that means hc, that is 1240 by 491 nanometers, students. This is one equation. In other case, that will be 1240 by, we don't know the x wavelength, is equal to work function of the metal will remain same in the second condition as well, but at that time the maximum potential is stopping potential is 1.43 volts, students. If you apply both the equations, eliminate phi, then you will be able to get what is the value of x, that is nothing but wavelength of the metal, students, wavelength of the light incident on it, students. So what you can go through these 2 equations and find out the value, that is to be lambda is equal to 382 nanometers according to the information and values that have been come on the memory basis, students. But students, so if you would have enjoyed these lectures, so what you can find is very, very interesting. The interesting part is you are going to get almost 90 classes by expert and experienced faculties as a crash course, as a part of crash course, analyzing all the papers that have already appeared and also the similar kind of concepts, on which concepts if you study you will be able to get easy marks by just knowing the fundamentals. So that kind of shortcuts, tips will be given to you in our Skyget app and also this live lectures. So you can join this app. Do you think, students, only the lectures will be there? You will have after class practice problems as well, and also live all India test series also, where you can compare yourselves with all the other competitors of you, where you are standing, where you need to improve, and where you can crack the examination, whatever that takes you to crack the examination. Students, interesting part is this, and also all this is for free. All this is for free. Join us, students. We will come back and we will energetically prepare for the examination. Thank you very much, students. Now the next part will be taken care by Vijay sir.
And hi students, voice వస్తుంది చూడండి. And hi students, and now we are going to start from the problem number 11. So where the sir has left. So here you have two particles having masses 4 grams and 16 grams. So he has given the two masses of each 4 grams and 16 grams. If the value of kinetic energy of both the particles is equal, then the ratios of the linear momentum is n:2. So he is asking this value small n. So what he had said here exactly is he is asking the relation between three quantities, and those are the linear momentum and mass and the kinetic energy. But he has given for those two masses the kinetic energy is same, so this is taken as constant. So here majorly you have to find the relation in between the linear momentum and also the mass of this both the particles. So what is the relation in between the value of P, M and K is the linear momentum P is equal to square root of 2mk, where here you can take the value of the kinetic energy as constant. Obviously 2 is also constant. So from this you can write the value of linear momentum P is and directly proportional to square root of mass. So he has said the ratio of the linear momentum is n:2. So P1 by P2 is equal to root over m1 by m2. So he has given the ratios to be n by 2. Then what are the ratios of masses? It is root over 4 by 16, that is root over 1 by 4. It is nothing but 1 by 2. N by 2 is equal to 1 by 2. That implies the value of n to be 1. So this is option 2. And next in the problem number 12, so here and these are the steps in which we have solved, but here we have taken the value of the kinetic energy to be a constant. So we have only taken the relation in between the linear momentum P and also the mass. So where P is and directly proportional to square root of the value of mass of the particle. Next in the problem number 12, he has given a gas follows PV power 1 by 2, that is P root V is equal to constant as shown. If V2 is equal to 2V1, then he is asking to find the ratio of T2 by T1, that is he is asking the ratios of the temperatures. So see here, first let us write what he had given in the question itself. He has given PV power 1 by 2 is equal to constant. But here this curve is varying with respect to P, V and T itself. As he is asking the ratio of the temperature, you have to write this in terms of the temperature. So obviously then it becomes, you can write, as you know, PV is equal to nRT. You can write P is equal to nRT by V into V power 1 by 2, that is square root of V is constant. So from this value of small n is constant, obviously R is constant, and T into root V by V you can write as T by root V is constant. So T by root V is constant means you can write T V power minus 1 by 2 is constant. So he has given the values of V and he is asking the values of T. Now you have the relation in between T and V. From this you can write T1 root over V1 is equal to T2 root over V2. As he asking the ratio of T2 by T1, so T2 by T1 is equal to root over V1 by V2. Okay. As you have the value of V1 and V2, obviously V2 is equal to 2V1, so V1 by 2V1, these both get cancelled, so T2 by T1 is equal to 1 by root 2. So that is option 1. Next, in the problem number 13, he has said in an amplitude modulated wave. So here the wave is amplitude modulated. So this is the key term in this problem. Next he said the message wave frequency is f suffix m and the carrier wave frequency is f suffix c. Find out the wavelength of amplitude modulated wave. So what does it mean, the amplitude modulated wave? Here amplitude is only modulated but not the frequency. So here what is the frequency with which this message is carried out with the help of a carrier wave frequency? See here, for example, in this class and I am speaking, suppose if there is no mic and here at this place, so obviously my voice can't reach to you. So here what I am speaking is the message signal, but it is not able to travel for so long distances. That is done by this carrier wave. So these carrier waves are used to travel the necessary and message signal for over and long distance, same as like in the cell phone. So here as it is only amplitude modulated, so there is no change in the frequency. The frequency with which this message is transmitted is equal to the carrier wave frequency fc. So that is the frequency with which this message is being transmitted. So find the wavelength. So what is the wavelength? He has given all the answers in terms of the speed of light. So that is the speed of an EM wave and also the frequency. So here the frequency would remain same, that is fc, the frequency of the carrier wave. So in general, as the signal has to be transmitted over the long distances, the carrier wave frequency is usually very high when compared to the message wave frequency. So as he said, the wavelength, as you know, speed of light or any speed of EM wave is equal to frequency into wavelength. Here the frequency with which it is transmitted is fc into wavelength lambda. As he is asking the value of wavelength lambda, lambda is equal to c by fc. So it is option 1. So it is option 1. Next, so there are in this question there are 2 columns. In the column 1 they have given 4 devices. First one is transformers, second one is the rectifier, third one is the filter, and fourth one is the stabilizer. So what these things do, you have to match with this. Obviously transformers are of 2 types, step up and step down, that is transformers are related to option Q. Next here B, which is the rectifier. What these and rectifiers do, they will convert AC to DC. Next it is filter. So filters will always remove the ripples. Stabilizer, so what does it do? What we use for the stabilizer in our homes. So even if there is increase in the input voltage, it would actually protect that particular device from that extra input voltage. That is, even if for any input the output would be same. So that is the function of the stabilizer. So here we have, so A, the transformer is step up and step down, that is A to Q we have done. So here for A to Q there are 2 options, option 1 and 2, and for the rectifier we have done from AC to DC, that is B is P, okay, again these 2 are there. Next C, filter. In this filter, by using them you used to remove the ripples, that is option R, C to R. Okay, then let us check for the last one, D, the stabilizer. For any input the output would be same, D, S. So it is option 1 here in this. So it is option 1. Okay, now we shall look after the next problem. In the problem number 15, he has given, for given logic gate circuit, which truth table is right. So he has given a logic gate circuit like this. He is asking which truth table is right. See here we can actually understand the problem in 2 ways, which is the general one, whereby using the rules and the laws which can be applied for these logic gates. Second one is the very shortcut one. So first I will tell the shortcut, then I will follow the general process. So first, if you look after the shortcut, see this is the input A and this is the input B. So A and this is one NOT gate. So NOT gate means A becomes A bar here. B, so B is applied to the NOT gate, this is B bar. So A to this gate of and what is applied, A and B bar are applied. So it is N means it becomes A into B bar. Next to the same AND gate, here the 2 inputs are B and A bar. So BA bar. So this is OR plus NOT, this is NOR gate. So in general it becomes AB bar plus A bar B whole bar. Okay, so first you have to add these both and then you have to complement them. First of all, if you know what is meant by XOR gate, in which when the two inputs are equal, then the output is 0. When the two inputs are not equal, then the output is 1 in case of the XOR gate. So here AB bar plus A bar B indicates an XOR gate, and you have to just complement the XOR gate. That is, if you draw the truth table, this would be the output. Okay, because first you have to, this is the XOR gate and you have to complement the XOR gate, then it becomes 1 0 0 1. So that is the shortcut if you can really understand, or otherwise there is the common process. So obviously you have got there AB bar plus A bar B or BA bar whole bar. So from this you can write AB bar whole bar into BA bar whole bar. So again you can write this as A bar plus B bar whole bar into B bar plus A bar whole bar. So as you know, B bar whole bar is simply B. So this is A bar plus B into B bar plus A. So these are the two processes. So this is a shortcut. If you know about the XOR gate, this becomes so easy, or else you have to do this process. Okay. So these are the various truth tables he is asking. So what is right? As we have seen with the shortcut, this is true because this is exactly the complementary of XOR gate. So in case of the XOR gate, this is like 0 1 1 0, but to the complementary, so you have to convert zeros into ones and ones into zeros, so it becomes 1 0 0 1. That is option 1. Okay. Okay, we shall move to the next problem. So this is the things what we have done now. Okay. Next, in the problem number 16, he had given one particle performing the simple harmonic motion on a smooth horizontal plane, and it is released from x is equal to a by 2 and it's moving in the negative x direction. So what is the waveform of an equation in which you represent a wave? That is what the thing you have to consider here now. So as you know, any wave is represented like y is equal to a sine omega t plus phi, or simply a sine phi. So here he has given it is starting from x, or the amplitude is equal to a by 2. So that is a by 2 is equal to, so that is a by 2 is equal to a into sine omega. Here as it is moving in the negative x direction, so take it is in the form of a cos wave. So that is a by 2 is equal to a into cos omega t plus phi. Okay, then a and get cancelled, so cos omega t plus phi is equal to 1 by 2, and for the cos omega t plus phi to be 1 by 2, omega t plus phi must be equal to 60 degrees, that is pi by 3. But he said it is been left at some point where x is equal to a by 2 and it is moving in the negative x direction. So whether you have to always calculate from the angle, or you have to take the reference from the x-axis. So already it is at an angle of 90 degrees there. So 90 degrees plus pi by 3. So that is pi by 2 plus pi by 3. So you will get the total angle to be 5 pi by 6. Next, in this problem, see, find the time period of the oscillation of a mass m. Assume the surface to be smooth. So there are two springs here. When this mass of m is being trying to be and oscillating, then what happens here? So here let the force caused by this spring is F1 and this be F2. If this block is been oscillating in this direction, first let us take it is oscillating in this direction, and obviously it will go back. So if you take in this direction, so here the total spring constant could be, as those two are in series and you have to add them, that will become 4k. So as you know, the time period is 2 pi by the omega, because the omega, the angular velocity or the angular frequency is equal to 2 pi by t. From this you can write t is equal to 2 pi by omega. as in terms of spring constant, as you know, omega is equal to root over k by m. If you substitute in this, it becomes 2 pi root over m by k. So here, as these two spring constant has to be added, this total value of k become 2k plus 2k 4k, that is 2 pi root over m by 4k. So it is option 2. Okay. So next, in the problem number 18, he has given for an extrinsic semiconductor, that means for an impure semiconductor, that is, it is doped semiconductor. So for a doped semiconductor, if doping concentration increases, so if you increase the level of doping, then what happens? He is asking. For the n-type and p-type semiconductors, Fermi level will increase. So that is option 1. And in the second, he has said that for n-type semiconductor, the Fermi level increase. For p-type, the Fermi level will decrease. First, let us understand what is Fermi level. After then, we will discuss about these 4 options. So first, let us see what is Fermi level. So Fermi level is a probable level of energy. When it is a probable level of the energy, here, as you know, these type of semiconductors can always be explained in terms of valency band and conduction band. Okay, first let us consider n-type semiconductors. So n-type semiconductors, these are generally doped with the pentavalent impurities, where it contains one excess level of the electron. When it contains the excess electron, these excess electrons are free electrons. So when these are free electrons, these are always present in the conduction band. So when there are more number of charges in the conduction band than in the valence band, so there is more probable level of energy for occupying towards the conduction band. So that probable energy level is called Fermi level, that is more closer towards conduction band in case of n-type semiconductors. While in case of p-type semiconductors, let us see. So p-type semiconductors are generally doped with the trivalent impurities. So these contain excess holes. These comes under the valency band. So there are more number of the charged particles in the valency band because of the generation of holes, because of trivalent impurities doped. So the Fermi level would be more close to the valency band in case of p-type semiconductors. First, now let us consider what happens if you increase the level of doping in both the n-type and p-type semiconductors. First, if you consider n-type, if you increase the level of doping, obviously the number of the negatively charged particles called the electrons will increase. So if there is increase in the number of the electrons, that is, those are free electrons, obviously this Fermi level will move upwards further towards the conduction band. That is, the Fermi level increases in case of n-type semiconductor if you increase the level of doping. If you consider now the p-type semiconductors, in this, if you increase the level of doping, obviously the number of the holes would increase. That is, this here the Fermi level would further decrease. Okay, so here by considering and all these factors, you can simply say that it is option 2, where in the case of n-type semiconductor the Fermi level will increase, and in case of the p-type semiconductor the Fermi level will decrease. Next, in the problem number 19, he has said that P cross G is equal to G cross B, and angle between P and G is theta, where theta is the closed subset of 0 and 360 degrees. So this is very important key term here, because he said it has the closed subset. So when the first you have to get that when the P cross G is equal to G cross P, this happen in 3 of the cases. First is whether P has to be 0, or else G has to be 0, or else the angle in between them should be 0 or 180. Okay, because as it is the cross product, the angle for this P cross G or G cross P to be 0, the angle, that sin theta, has to be 0, which only occurs at angles of 0 and 180 degrees. If you take that subset, so that is the closed subset and that is not the open subset. So after that, as it is closed one, there is no need to consider 0. So obviously the answer is here the angle has to be 180. Next, in the 20th one, he said if the tension is increased by 4% in the vibrating string, then the percentage change in the speed of the wave. That is, you have to get a relation in between the speed, tension and also the density. So that is V is equal to root over T by mu. So here you can use the dimensional analysis to find the change in speed, that is he is asking the percentage change. So here you can apply the same formula what we have learned for the percentage error here for percentage change. So the percentage change in the value of V is delta V by V into 100 is equal to, he said, or he is asking only about the tension T. So V is and directly proportional to square root of tension, that is V is proportional to T power 1 by 2. So this is in powers. What you have to do, you have to simply and multiply that with the percentage error of tension T. So that is delta T by T into 100. So he has given the percentage error in the value of the tension T. So obviously you have this value, so half into what he has given the percentage error to be 4 or the percentage change to be 4. So it is 4 by 2, it is nothing but 2 is the percentage error in the speed of the wave on this string with tension T. Okay, so this is the numerical one where we got option to be 2. So this is what exactly we have done. So here in the Skyget app, if you download the Skyget app, where you will get all the classes by all our and senior and very well experienced and trained faculties, and you will get all the crash courses and all the previous problems from JEE Mains, where you get at least 60 to 70% of the problems in each and every year of mains. So if you once look at the previous year problems and their and solutions, it would be very useful for your mains exam. So please like and share and subscribe the app if you want, and all these you can get for free here. So, and you can understand the importance of this. So from now on, and our sir will and continue the class. My God. And I will hold it, you can put it. Insert.
Hello. Okay. Hello students, welcome back. So I hope you understand, you understood the kind of question that our faculty member were teaching you. So as we again and again telling you that kind of question that you are watching in JEE Mains, these type of the same questions are already in our app, that is in Skyget. If you come and if you start giving the mock exam, you are going to score better and you will able to reach somewhere, you will land somewhere in very good universities. Now up to question number 20, they made the question super easy. Let's see the question from 21 which came in your exam. And in this case, they are saying that Carnot engine, they have given in a Carnot engine, they have given this is the first condition. Okay, so whatever the efficiency they have given, that is work done over total how much charge do you have supplied. That is the ratio of both of them is 1/4. In second case, they are saying if the sink temperature is decreased by 52 degrees Celsius, then your efficiency becomes this much. Find out the source temperature in degrees Celsius. So what is the meaning of source and what is the meaning of sink? So for example, let's suppose this is my source and this is my sink, and your Carnot is working between these two. So if this is your T1, this is your T2, so the efficiency of the Carnot is given as total work done over total whatever the heat you have supplied, or in other term you can write it as 1 minus T2 over T1. This is also one of the formula. Understand? So in this case, they have given the efficiency that is 1/4 equal to minus 1 T2 minus T1. Understand? So from here, if you solve this thing, if you take 1/4 this side, so I guess T2 minus T2 over T1 will become 3/4. Why? 1 minus 1/4. So 4 into 1, that is 4 minus 1, that is this thing. So 3/4, this is your first equation. In second case, what they are saying that when you decrease the sink temperature. Okay, so if this is was T1, this is your T2. Now new case you have to decrease by T2 minus 52 degrees Celsius. This much temperature you have to decrease. In that case, your efficiency becomes 1 over 2. So in again we can do the same thing. We can use this formula. So 1 minus T2 minus 52 divided by T1. Okay, so again if you solve, T2 minus 52 divided by T1 will give you 1 over 2, because this is 1 over 2. If you just send this side, 1 minus 1 over 2 will be half of that value. This is equation number 1. This is equation number 2. If you just divide equation 2 divided by equation 1, you are going to have the value that is 52 minus this value divided by over here should be T2 minus T1, and this somewhere you will end over here. So 1 over 2 divided by 3 over 4. This is the numerical which you have to solve in that way. So 2 and 2 is gone. Sorry, T2 minus 52 over T2 is going to be 2 over 3. If you cross multiply, this is going to be 3 times T2 minus 3 times 52 is equal to 2 times T2. If you subtract that value, I hope T2 is going to be 3 times 52. Since you are writing the exam, you don't need to multiply all the time. You can keep this value as it is, because you need to find out the source temperature. Since you need to find the source temperature, I can write from this equation that T1 will be equal to 4 by 3 times T2, and 4 by 3 times T2 is 3 times 52. 3 and 3 is gone. 4 times you just multiply it. So 4 2s are 8 and this is 20. So this is going to be the value of your source temperature. This is how you have to solve your numerical. So I hope you understood the process. The process was super easy. Very good question. See how to solve this equation. In this question, they are saying that from this direction somewhere here, the 6 ohm and 6 ampere current is coming. Now, at this is the junction. We know that at the junction current will divide. So in this direction we have I2, and in this direction you have I1. So what they are asking, find the value of I1. Okay, they are asking the value of I1. So what you can say, boss, your current I2 is reaching R from this path, and your I1 is coming from this path. So if you try to understand very carefully that even if we have 2 ohm and these 2 ohm, they appear as if they are in parallel, but they are in not parallel. Why? Because the current is not getting divided, and if current is not getting divided, it means they are in series circuit. So in place of this thing, what I can say, I can draw one circuit like this. So since these two are in series, so I will have 4 ohm, and again this is this value 2 ohm, and from here your current will be whatever the current is coming. So this is 6. Over here we have I2. This is I1. This is how you can rearrange the circuit. Now you need to remember that since we know these two are in parallel circuit, so in parallel circuit we remember that voltage remain same. So I1 over I2 we have to find. So since I can say, since voltage remains same, so I can write I1 R1 equal to I2 R2. So I1 into R1, R1 will be 4 and I2 we have to find, and R2 is going to be 2. But since from here, from junction rule, we already know that 6 can be written as I1 plus I2. This is your second equation. If you solve these two equations, simple thing, I1 is what we have to find, I2 find, I2 we have to find. So I'm just going to I1 we have to find, so I'm going to replace the I2. So 6 minus I1, this will be my equation. If I place this value somewhere here in this I1, I can write 6 minus I1 equal to 6 minus I2 equal to I2 times 2 times of I1, this thing. So 6 equal to 3 times of I2, and so I2 is going to be nothing but 6 over 3, that is 2 ampere. Simple current and voltage question. I hope you understood the logic. Okay. Now they are saying there is a one satellite which is projected, very good question, satellite projected from the earth so that it can attain the height of 10 r from the surface of earth. It means this is your earth, it has radius of r. From surface of r, let's suppose you are projecting one missile. Okay, this is your missile, boss. Okay, you are projecting. Now what they're saying that it is able to reach up to this height, for example, whatever this height may be. So from here, this is your 10r from the surface. Now its speed at the surface is, they have given, you have to find out this speed. Actually they are saying that their speed is some function of this value, like that. Okay, so they are asking to find the value of x. So simple thing, if you remember, what is the equation for v escape? What is the v escape? What is the escape velocity? Escape velocity is a minimum velocity which is given by given from Earth, so that your satellite is not in contact with the Earth and it is able to move away from the gravitational field of Earth. Right? In that case, what you can do, you can conserve the energy. Initial point, final point, conservation of mechanical energy, kinetic energy plus potential energy, kinetic energy plus potential energy. Infinity, we assume that particle is at rest. Infinity, we assume that potential energy at 2 point will also be at rest. So you can conserve the energy, and let me write how to find out this. Ki plus ui is equal to k final plus u final. We assume that when it is at infinity, final velocity will be 0. When it is infinity, so we know that what is the formula for gravitational potential energy. So this is G m1 m2 divided by r. So since you can say the value of r become very high, so these two value can be neglected. And if this is can be neglected, so k initial will be equal to u initial, and k initial equal to half of mv square equal to this become positive. So G capital M into m divided by r square. This is your gravitational potential energy from here. From here, if you place the value, you will get the velocity, right? This is your velocity. So escape velocity you are able to find out from this equation. You just need to place the value over here and you will able to get your answer. Same thing what you have to do at this point, you have to conserve your energy. So initial is there, final you can place into 11r and you will able to solve these things. So the main important today we are going to discuss about the logic. Numerical part is up to you, you have to solve that. Okay, because I am expecting the kind of the viewers we have, they are able to solve these things. The only important thing is the logic, how to and where to explain the logic and how to apply the logic, because calculation is good for everyone. Okay, you can see that how to find out that value and then you can compare this. Okay, two conducting charge but negligible volume close to charge this respectively are brought in contact with that, then separation become this thing. Force of interaction is very good question. Now see, very easy question. I hope it's not going to be that easy, not that difficult, because two charges are there and their separation between distance is there. You have to use the Coulomb's law, and if you apply the Coulomb's law, that is 1 over 4 pi epsilon naught q1 into q2 divided by distance square. If you place that value, you are going to get the force, and just equate that force equal to this value. From here you will get x. So simple. I consider this to be a very easy question. I hope even if the grade 12 student can do that, there was not so difficult things. Particle is dropped from top of the tower. When it has traveled a distance of 5 meter, another particle is dropped from distance of 25 meter below the top of tower. Okay, if both of them reach the tower at the simultaneously, then what will be your, what they're asking, find the height of the tire, this thing. So let's suppose what I can say, boss, let's suppose this is my tower, this total height is h, this is object 1, and the second object will be somewhere here, because they are saying that 25 meter below. So this height is 25 meter. Now it means if it is released from here and when it has traveled a distance of 5 meter. Okay, so as soon as when it has traveled the 5 meter, another particle drop from 50 below. Okay, so for example, what we are assuming that it has traveled only 5 meter from here, but that time the second particle which is at the below of 25, it start moving. Right. So what we can assume from here, that let's suppose how much time it has taken and then how much time was this value. Okay, right. So you can do that simple problem. Again, I consider it to be very easy. How can you do that? Let's suppose for this is for A, this is to B. Okay, now if I assume for A, let's suppose for A, how to calculate this value. So for A, you can say when it has reached from, let's suppose, your x to y, which is 5. So displacement is equal to ut minus half of gt square. Since it is moving toward downward direction, displacement is your vector quantity. It has to be minus 5. Initially it is dropped, so velocity is 0. Negative half in times 10 into t square. This become 5 minus cancel, t equal to 1 second. It means after 1 second, After 1 second, it will be at 5 meter. Okay. So now try to, and up to here I hope there was no problem. But after 1 second, let's suppose the time taken by this object to reach over here, this is t and this is also t. Understand? So they are saying that both of them reaches the same height, or both of them reaches the basically ground at the same time, right? So what equation you can use from here? You can say that let's suppose if it is taking time t, this must be taking t plus 1 time, because if we say that two objects are reaching at the same time, it means let's suppose consider 2 seconds. So it means the first has already covered 1 second, right? So in that time, what I can say that let's suppose to reach, this is your height h. So for a, I can write h equal to minus of half into g into t plus 1 square. I hope you understand. And for the second, for b, I can write that h minus 25 is going to be minus of half of g into t square. Why we are assuming this? Because for 1, the time taken will be t plus 1. T plus 1 means from that time it is releasing. Then simple thing, you just do the calculation and you will able to find this value. Just subtract both of them, you will able to get that value. So this is equation number 1, this is equation number 2. Let's suppose from 2 minus 1 if I do, both of them are negative. So h minus 25 minus h equal to minus of half into g t square plus half of g into t plus 1 whole square. This, so h cancel out, minus 25. If here we have minus, here we have positive. If I take the minus common and cancel out, so this will cancel out, this will become negative, this will cancel out. So from here, if I after cancel out, I can write 25 equal to half of g, if I take common, so this will become t square negative t square minus t plus 1 whole square. Simple thing, a square minus b square equal to a minus b, a plus b. So what will happen over here? 25 equal to 1 over 2 into 10 equal to t minus 1 into t plus 1. T and t cancel out, 2t here, only one variable, simple, get your time. So after solving that, you will get the time that to be 45 seconds, 45 height, okay. After that, for a X-ray, it is the wavelength. They have given this much mass of this value. Simple question. I don't find the very difficulty. The question is saying that there is X-ray. Same X-ray, whatever the wavelength is that, and whatever the energy of that X-ray is, same. There is one particle of mass m, and it is moving with some velocity. And they are saying that for energy for both of the particles is going to be the same. And when the energy for the same, so how can we correlate? So if any particle is moving, that is have kinetic energy. If there is X-ray, for X-ray we know that the formula for that is hc by lambda, right? So if you equate these two equations, you are going to get the results. So simple. I consider it to be very simple question again. For students who are the regular follower of our channel and that's watching the videos every time, they are going to solve these questions very smoothly. Understand? So just hope. So these are the solution. If you solve all these things, you are going to get results. Simple. I told you the logic. Most important thing is to understand the logic, because physics is all about logic. You have to be very sharp in order to apply the concept and how to use and where to use. Because in JEE Mains, they don't ask the question from out of the box. They only correlate 2 or 3 concepts and they make the question. And how will your mind will work? That will work after joining our classes. If you join our classes, if you download the Skyget app, you will find so many questions are there, and these questions are very helpful. They are designed for your JEE preparation. From here, if you solve this question, follow our lectures, and if you give the practice kind of things, if you follow properly, if you give your practice, there will be a lot of the rank will be decided, and from that rank you can analyze where you're standing in among the student across India. So with this, I hope you like the lecture. Okay, so you can download, you can come and you can have the fun. Okay, because learning has to be the fun, right? So we will do a lot of the things. Okay, very important. Then right now the crash course is on with us. You can join every day. We are having in days, we have chemistry, physics and your mathematics lecture keep coming on every 1 hour. So you can contact us, you can always call us, you can visit our site, download the app, and then you will get a notification for what are the logics and what are the time in which your live session will be there. So I hope you enjoy the lecture, you use the platform to get the maximum benefit. Thank you very much.